In this video, we will learn how to write an arithmetic sequence using the recursive and explicit formula, and then use those formulas to model real-world situations. Here's our first problem. Is the ordered list 26, 39, 52, 65, and 78 an arithmetic sequence? So before we can answer this, we have to first define some terms. First of all, an arithmetic sequence, when you see this word, you might be thinking, wait, isn't this arithmetic? So when we use this word as a noun, that would be pronounced as arithmetic. If we're using it as an adjective to describe this sequence, we say it as arithmetic. So this video is focusing on arithmetic sequences. So the main takeaway from this is that the order of the numbers does matter in the sequence, and the difference between the numbers that are next to each other should be consistent. In this case, it's always adding 13. How are sequences related to functions? You can think of a sequence as a function where the domain is the natural numbers because the domain is going to represent the term number, and the range is the actual terms of the sequence, so the actual values of those terms. For the sequence that's listed there, we're going to let n equal the term number in the sequence. So if we're comparing this to the function, that would be comparable to the x values or the domain. Then we would let a of n equal the value of the nth term in the sequence. So that would be comparable to our y values or our range if we were going to think about it as a function. If I wanted to find a of 1, that would be the value of the first term, which would be 26. Looking at this, this is my first term. If I wanted to find a of 2, that would be the value of the second term, which is 39. When I look at this, that is my second term. How do you represent sequences using subscript notation? Subscript notation is commonly used to describe sequences. We have used subscripts before in the slope formula and in the point slope formula. So just as a reminder, whatever the subscript is, it's just used to represent different values. It doesn't mean that we're multiplying anything by 2 or squaring things. It's not an exponent. It's just another form of notation. So when we have subscript notation, the number that's used as the subscript is to represent that term number. So in this case, this 2 here represents the second term. So in order to say this out loud, anytime we have a subscript, we will say a and then sub, meaning subscript, and then whatever the number is. So to say this equation, we would say a sub 2 is equal to 39. If we had this here, that would be a sub 3, and then later on we will have formulas where we're using the term number, and the term number is unknown, so we'd represent that with a sub n. Now we're going to learn the recursive formula for arithmetic sequences. So recursive in mathematics means to repeat a process over and over again, using the output of each step as the next input. A recursive formula relates each term of a sequence to the previous term. It is composed of an initial value and a rule for generating the sequence. The recursive formula describes a pattern of the sequence that can be used to find the next term in the sequence. What is a recursive formula for the height above the ground of the nth step of a flight of stairs? So first we have to determine the first term in the sequence. That's going to be the height of the first step, so that's 26. To use the recursive formula, I need to figure out the common difference. So to find that, I have to figure out how the values are changing in the sequence. So I can see that with each of these, it is increasing by 26 centimeters, so D will also be 26. We can use this formula to come up with the height above the ground of the third step. So basically what I'm trying to do is figure out what a sub 3 is. Well, to figure out what a sub 3 is, using this idea I'm plugging in 3 for n, that means that a sub 3 is going to be equal to a sub, then it would be n, which is 3, minus 1, plus 26. So when I simplify this, 3 minus 1 is going to be a sub 2 plus 26. So if I knew what a sub 2 was, I could just take that value and plug it in here. However, I don't know what a sub 2 is. So in order to figure out what a sub 2 is, I have to then use the formula again, but instead of plugging in 3 for n here, I'm going to plug in 2. Now I have something that I do know. I actually can take this value for a sub 1 and plug it in to a sub 1 there. So I can plug in 26 for a sub 1, so I'll get 26 plus 26, that will equal 52. So I know that a sub 2 equals 52. Now that I have this information, I can take that and plug it into a sub 2 here. Plugging that information in, I learned that a sub 3 is equal to 78. Therefore, the distance from the third step to the ground is going to be 78 centimeters. When we look at the recursive formula, it's kind of a lot of steps to end up trying to find our value. In this case, we had this scenario where we wanted to figure out the height from the ground to the third step. So in order to do that, we had to first figure out what a sub 2 was. And then to figure out what a sub 2 was, we had to first find what a sub 1 was. So we took that value and plugged it in here, and then found our value for a sub 2, and then plugged that back in here, and then got our answer. So it kind of took a lot of steps, and the reason why was because the recursive formula builds on top of the value of the previous term. So if you don't know what this value is of the previous term, it takes some time to get your final answer. So we have another formula that's called the explicit formula that gets us there a little faster. The explicit formula represents the nth term of a sequence in terms of n. So the explicit formula for the arithmetic sequence is a sub n equals a sub 1, which is the first term of the sequence, plus, and then in parentheses, n minus 1, which is the previous term number, and then multiplied by that common difference. So the cost of renting a bicycle is given in the table. How can you represent the rental cost using an explicit formula? So to figure this out, we need to think about how our values are changing. So these values here at the top, 1, 2, 3, and 4, these are going to be representing our term numbers. And then these values here are the values of those terms. Because there is a common difference between each of these consecutive terms, we know that this here is an arithmetic sequence. So since it's an arithmetic sequence, now I can represent it using the explicit formula. So to come up with the explicit formula for this problem, I'm just writing out the formula first. Then I know that a sub n is going to equal, just starting to plug things in, a sub 1 we know is the value of the first term. So the first term here in our sequence is 26. So I'm going to put 26 in for a sub 1, and then plus my nth term, which I don't know what that is. I'm leaving it as n, just like in this formula, this part here, n is left here. I'm going to leave n here because we don't know what term we're going to be solving for. And then minus 1. This value is in parentheses, and it's being multiplied by our common difference. We figured out that our common difference was 12. So I can put 12 here, that it's being multiplied by 12. So using the distributive property, I'm going to multiply 12 by each of the inside terms. Combining like terms, I get a sub n equals 14 plus 12n. If I wanted to figure out the cost of renting the bicycle for 10 days, that means that I'm going to be plugging in 10 for n here. So when I plug in 10 for n, I'll end up getting 134. That it will cost $134 to rent the bike for 10 days. So this process of using this explicit formula is much faster than it would have been had we had to use the recursive formula, because in order to use the recursive formula, just as a reminder, that looks like a sub n equals a sub n minus 1 plus d. If I wanted to find the value of a sub 10, I would have to first find the value of n minus 1, so 10 minus 1, the ninth term, and then add my common difference. So in order to do that, I have to figure out what the value is of the ninth term. And then to figure out what the value is of the ninth term, I have to figure out what the value is of the eighth term. So then it continues to build on top of itself. So if I already have the explicit formula, I could just plug in 10 in for n and then simplify to end up getting my final answer, instead of using the recursive formula where I have to figure out all the previous terms to then get the value of the term I actually want. How is the explicit formula of the arithmetic sequence related to a linear function? So when you compare the explicit formula of the arithmetic sequence in black to the linear function and the linear equation in red, we should notice that all of these equations are the same. They're the same thing. There's going to be a slight difference in meaning with the arithmetic sequence, and I'll get into that in a little bit, but first let's continue just talking about the similarities. So in our linear function, we can clearly see that our slope, or our rate of change, is 12. Because that is a number that x is multiplied by. We can rewrite this as 12 over 1. So the slope of it being 12, or the rate of change being 12, is the same for our arithmetic sequence, except instead of calling it the slope or the rate of change, we call it the common difference. And so our common difference in the arithmetic sequence is 12, and that represents the same thing. We're saying as the term numbers increase, which is our 1, as the days increase, the charge, or our change in y, at the top is going to be an increase of $12. Now let's talk about what 14 represents in each equation. So this value here, 14, in either form in the function one or in the just regular linear equation, this 14 represents our y-intercept, right? That's where it crosses the y-axis right here at 0, 14. In context of the problem, when we think about it as an arithmetic sequence, that's these values here in blue, it doesn't really make sense for us to include the value of day 0. Because think about if you're renting a bike, if you're going to rent a bike, in this model, how they have it here, since they're charging you by the day, they wouldn't charge you for having it be 0 days, right? The shortest amount of time you could rent the bike would be for 1 day. So having this value where we have 0 days or term 0 doesn't really make sense in context of this problem. So when we have an arithmetic sequence representing this, we can see that each of these values, the term numbers, 1, 2, 3, these are counting up by ones. We're not including the values in between these. And we're starting with day 1, that's the smallest number of days we could include, and then continuing to 2, 3, counting up all the way until however many days we want to rent the bike. So that is why here we have separate points that we aren't connecting to make a line. So as we had talked about earlier, in an arithmetic sequence, our domain is just the natural numbers because it's the number of terms. So counting up by ones. We're not including 0 because it doesn't make sense in context of our problem to include 0. So we use this plus 14 as a part of our formula to come up with our final answer, but it doesn't really have any meaning in context of this problem. Unlike with these plus 14s, right, these hold meaning because it represents our y-intercept. The cost to rent a bike is $28 for the first day, plus $2 for each day after that. Write an explicit formula for the rental cost for n days. What is the cost of renting the bike for 8 days? So when I plug this in using my explicit formula, I'm going to plug in $28 for the first day, that will be a sub 1. $2 for each day after that represents my common difference, so I put that in for D. And then I distribute and solve. I end up getting a sub n equals 26 plus 2n. Then to find a sub 8, I'm going to plug in 8 for n and then simplify. So it ends up being that it would cost $42 to rent the bike for 8 days. In this next example, we're going to use the recursive formula to then come up with what the explicit formula should be. So here we're told that the recursive formula is a sub n equals a sub n minus 1 plus 4, and the value of the first term is 7. So when we look at this, we can rewrite this information. We know the first step is going to be 7 inches tall. Every other step is increasing by 4 inches, so our common difference is 4, right? In our original formula for the recursive formula, this here would be D, and D represents that common difference. So when we want to come up with the explicit formula is this, where I just take those same values. I can take what a sub 1 was and plug that into a sub 1 here, and then take what D was and plug that in for my common difference. And then all I have to do is just distribute and combine like terms. So then once I plug in these values for a sub 1 and D, I end up just getting this simplified answer that a sub n equals 3 plus 4n. So now do the same process. Try to write the explicit formula for each of the arithmetic sequences. So remember that in the recursive formula, this value on the end is going to be my common difference. Since this is a minus 3, that means that my common difference is negative 3. So when I have D, I'm going to plug a negative 3 here. A sub 1 is my first term, so that goes here. And then I simplify. For this one, it's okay to have a common difference that is a decimal or a fraction. That's perfectly fine. This I'm just going to plug in for my D here for the explicit formula. And then a sub 1, I plug in that a sub 1 spot and also simplify as well. So now let's do it in the opposite order. We're going to find the recursive formula when given the explicit formula. So this is actually even faster. When we want to find the recursive formula, all we have to figure out is just what D is, what the common difference is. So the common difference is always going to be whatever our term number is multiplied by. So to write the recursive formula, all we have to do is just take that common difference of 1/2 and put that in for D. So my final answer should be a sub n equals a sub n minus 1 plus 1/2. The last thing we have to do is to figure out what the value of a sub 1 is, that first term. And so all I need to do is just plug in 1 in for n, and then I end up getting that a sub 1 is equal to 3/2 or 1.5. Write a recursive formula for each explicit formula and also find a sub 1. So since this is D, I'm going to just put that into my formula. The rest of this stays the same. To figure out a sub 1, I just put in 1 into this formula here for n. I end up getting that a sub 1 equals 11. So this is what the recursive formula and the value of the first term would be for this particular arithmetic sequence. For this next one, I look at the number that n is being multiplied by. This is a negative 5, so that means that my common difference is minus 5. From here, I'm going to plug in 1 in for n, and I end up getting that a sub 1 equals 7.